Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss the final tutorial for benzene and its derivative, which will cover for non-face-to-face and face-to-face questions week 11 hour 1. We're going to start by completing the following reactions. So given to you a benzene to react with 1-chloropropane with the presence of AlCl3 to form compound X. We're going to say that these reactions involve electrophilic aromatic substitution since we got only benzene to start with. We aim to substitute one of the hydrogen with this alkyl group. But please bear in mind, whenever we have a number of carbon, we need to check for their stability because we are going to form carboxylic ion throughout the reactions, means we're going to have a number of stability we have in this structure. So we'll have primary, secondary, and primary carboxylic ion to be formed. We are going to form major product, so we're going to attack the secondary carbon so that our final structure for compound X gonna be isopropyl benzene because they attack at this carbon. And then by having isopropyl benzene, we're gonna react them with reagent Y to give benzoic acid. Since we have benzene and also alkyl group attached to it, so we need to decide which of those will undergo these reactions. Once you have alkyl group attached to the benzene, means they are susceptible to be attacked at these alkyl parts. So means that the reactions that will take place will involve the side chain. So we only have two reactions that involve the side chain of the benzene. It's either halogenations and also oxidations. So for Y, since we are going to form benzoic acid, means we are going to perform oxidation. So oxidations, we're going to react them with potassium permanganate, H+, with the presence of heat. So how do we know that they're going to form this benzoic acid? So we need to look at this isopropyl benzene. We need to first check whether we have benzene. Yep, we have benzene. And then look at the first carbon that is directly attached to the benzene. Do they have any hydrogen on it? So we have one hydrogen in here. This indicates that this is a benzylic H. Once we have benzene and benzylic H, means we can perform oxidation reactions to give you benzoic acid. And lastly, by having this isopropyl benzene, we can also undergo halogenations with the presence of UV in order to undergo the free radical substitutions. We've already learned about this in chapter 5, where we know that this is gonna take place at alkene. So we also have the stability of free radical, so we need to always check for the classes of free radical that can be formed during these reactions. So look at the class of carbon in here. We have 3 carbons. They got primary, and also this one is tertiary. So between primary and tertiary free radical carbon, tertiary free radical carbon gonna have the highest stability. So therefore, we're gonna substitute one of the hydrogen with Br. So our final compound Z gonna be like this. So we have Br being substituted. Don't forget the double bond in the benzene. Moving on to the second questions, where you need to show how each of the following compound can be prepared from benzene. So for A, we have benzyl chloride. So we need to first draw the benzene structure. So our benzene is a cyclic compound with 6 carbon together with 3 double bond. And then we're going to form this benzyl chloride. See, we have already learned about the benzene as substituent. Benzyl means we have benzene, and we have additional carbon in here. When we have benzyl chloride, means at this carbon we're going to have chlorine attached to it. Out of the 6 reactions we have learned for benzene and its derivatives, is there any reactions that can directly transform this benzene to become benzyl chloride? No, that's why we need to do the synthetic pathway. For the benzene itself, we only have 4 reactions. It's either halogenations, nitrations, Friedel-Craft Alkylations, or Friedel-Craft Alkylations. So in order for you to know which of the 4 reactions going to take place for these reactions, look at your product of benzyl chloride. Initially, we have benzene of 6 carbon, but on your benzyl chloride, we have additional carbon in here. It means that we need to first add carbon to your benzene. So out of the 4 reactions, we're going to proceed with Friedel-Craft Alkylations. So how do we know what kind of alkyl halide to be added? Look at the number of carbon attached to this benzene. You only have 1 carbon, means you're going to add only 1 carbon. And then on your alkyl halide, you need to have 1 Cl at least. It means that the others belongs to the hydrogens. So we're going to add CH3Cl with the presence of your catalyst of AlCl3 or maybe FeCl3. By doing this, you're going to get your methyl benzene. From your methyl benzene, how are you going to add your chlorine? So look here, we want only the chlorine, and in your structure, you happen to have both benzene and also side chain. If you have side chain of alkyl group attached to the benzene, always go for the reactions on the side chain. So our side chain got only 2 reactions. It's either oxidations or halogenations. Since we are going to add halogen, means we are going to undergo the halogenations reactions involving Cl2 with the presence of UV. Next, show how the benzene can be transformed into benzoic acid. So we know we are going to repeat our steps up here. We'll start with this benzene. Then we're going to form benzoic acid. So this time around, you are going to form carboxylic acid. Again, we got only 4 reactions, and out of the 4 reactions, none of the reactions will give you benzene to form benzoic acid. We know that benzoic acid can only be formed from benzene with side chain. So we need to first form our benzene with side chain. In order for these reactions to happen, they need to obey the requirement, which are benzene and also benzylic H. So it doesn't matter of how many carbon that you are going to add to this benzene, as long as they got benzene and also benzylic H, then only they can proceed to form this benzoic acid. So you can react this benzene with any classes of carbon that has hydrogen attached to it. So it can be either methyl, primary or secondary carbon, not the tertiary carbon because you got no hydrogen attached to it. So let's try another alkyl halide to be added. Let's say we have secondary alkyl halide. We have CH3, CH3, and then we have Cl in here. Then we're gonna get our intermediate structure of benzene. Then we have this isopropyl group attached to it. So how do we know that we can proceed to form the reactions with KMNO4, H plus, and also heat? By looking at your intermediate structure, we have benzene and we have benzylic H. Once we have these two, we're going to get benzoic acid as the product. For face-to-face questions, you are given a questions that got massive information given, then you need to extract them one by one. So compound T is formed from the reactions of benzene with chloroethane. So you need to first write the reactions. We have benzene, and then we're going to react them with chloroethane. Means we have 2 carbons, CH3, CH2, and then we have Cl attached to it in the presence of AlCl3. So we know that this is Friedel-Craft Alkylations. We're going to have our T compound. And then from this T, we're going to undergo this chlorinations process. Chlorinations means you are going to react with chlorine, Cl2, in light. So you need to write light. So we know that reactions of halogen with light gonna give you free radical substitutions, and it also gives you information regarding compound to be formed. Monochlorinated compounds means only one chlorine to be substituted at once, but then you have two of them. So you're going to have U and V, where your U going to be the major product. So you must be really careful with these classifications. And the last statement states that the treatment of T in acidified solutions of CaMnO4, so we're going to write it as CaMnO4, H plus, and also heat, going to produce W. Right. So now the first question asks you to draw the structures of compound T, U, V, and W. We'll copy the whole draft to the next page. So now we have these reactions. We're going to determine who's going to be the T, U, V, and W. So since we are going to add this alkyl group to this benzene, means we're going to get our compound T of ethyl benzene. So for this ethyl to be added, there's no room for rearrangement because we only got primary and also primary carboxyl ion to be formed. That's why we're going to have only this structure. And then once this compound T reacted with Cl2 in the presence of light, means we're going to do the free radical substitutions. So benzene will stay as it is, but then the only part that changes is the one at this side chain. So we know we have 2 hydrogen in here and also 3 hydrogen in here. The major product going to be the one at carbon number 1, since they have secondary free radical to be formed. So we're going to keep these 2 carbon and then simply substitute one of the hydrogen with the Cl. Okay, that this is U. So this is U. This is T. What about V? Because the questions also ask for V, means the V gonna be the minor product. So we also have benzene and 2 carbons, but then the substitutions will happen at the second carbon, where you're gonna have Cl, H, and H. So we have benzene in here. Alright, and for the last one, by having this ethyl benzene, we're going to react them with CaMnO4H plus heat, means this is oxidation reactions. Look, if we have the benzene, yep, we have the benzene, and also we have benzylic H, then our only product of W will be benzoic acid. As for the last questions for this tutorial, we need to show the mechanism for the formations of compound T. So we know that we are going to form ethyl benzene from benzene. Then we need to do the 3 important steps involving electrophilic aromatic substitution. So we'll start with step 1. We're going to react the CH3 CH2Cl, show all the lone pair, react with the AlCl3. Show the curly arrow from this lone pair to Al, then you will form complex ion of CH3, CH2Cl, that is left with only 2 lone pairs, and we have AlCl3 attached to it. Don't forget the positive charge in here and also negative charge in here. How do we know whether we are going to take this complex ion to the second step or not? Look at the alkyl group attached to it. We have 2 carbons. Look, if we happen to break the bond between this C and Cl, we're going to form carboxyl ion. The carboxyl ion to be formed at this carbon going to be primary. If we change the positive charge of this carbon to the next carbon, we're also going to get primary carboxyl ion. And we know that primary carboxyl ion has less stability as compared to secondary and tertiary. Therefore, for our step 2, we need to bring the whole complex ion into these steps. So we're going to form arenium ion. So we need to react this complex ion with benzene. So we have CH3, CH2Cl. This is positive, this is negative. So show the curly arrow to take this carbon, and then don't forget to break the bond between this C and Cl to get your carbocation. Alright, now we're going to form resonance as we involve the reactions with benzene that got multiple bonds. One of the bond in the benzene has been broken, means we are left with only two double bond. Don't forget the positive charge on this carbon. So we have H, CH2, CH3. We know that resonance involves the movement of pi electrons, so we are going to move these pi electrons to this place, and then we're going to show the resonance by using this arrow. Having this arrow and swapping place, we're going to get double bond at new locations, means this carbon going to be the positive carbocation. Then we have H and CH2, CH3, and as for the last double bond, we're gonna move the pi electrons to here. Lastly, our resonance structure gonna be like this. 1, 2, H. Okay, so don't forget to close your bracket. Now, take one of the resonance to proceed to the step 3. So step 3, we want to retain our double bond inside the benzene. So we need to redraw the one of the resonance. So let's say we have this resonance structure, H, CH2, CH3. And from the second step, since we've already broken the bond between C and Cl, we're going to reuse this AlCl4 minus as the nucleophile to take the hydrogen out from this carbon. So we need to first break the bond between this Al and Cl, give all the electrons to the Cl, making them nucleophile, and then take this hydrogen, and lastly give back the bonding. So we'll get our final product of ethyl benzene. Don't forget your side product as well as the catalyst that has been regenerated. That's all for this chapter. Thank you.